Welcome, fellow chemists, to a video about balancing more complicated chemical equations. If you tried the last practice on the previous video and got stuck, time to reveal how it's done. First, you need your initial count of atoms. The left is easy, and on the right, carbon and hydrogen are simple enough, but oxygen is in two places, so add them together to get the total. Looking at it, with one butane on the left, you need to quadruple carbon on the right. This increases the amount of oxygen to 9, and then you need to increase the hydrogen 5 times, which increases the amount of oxygen to 13. Oxygen remains, and turning 2 into 13 requires multiplying by 6.5. Case closed. Uh-oh, now the chemistry police, even tougher than their grammar counterparts, are after you. How dare you violate Green Book page 45 convention 2.10.III, which states 1/2 oxygen, 1/5 potassium permanganate, and 1/2 sulfate are artificial in the sense of fractions of a molecule cannot exist. But you argue, so what? I balanced the equation, and furthermore, even your Green Book uses fractional coefficients on the very next page, twice. The officer replies, true, but Goldbook version 2.3.3 states in a chemical reaction equation the coefficients next to the symbols and entities are the absolute values of the stoichiometric numbers. Excuse me, sir, stoichiometric? Ah, the guy making the videos hasn't told you yet. Nope. If he stopped this bit, he'd be closer to doing so. Probably, but until then, can you tell me instead? Ah, yes, it means chemical combination in simple integral ratios. Since your equation is in violation of it, it is time to go to jail. You will not pass go and not collect $200. Wait, if this is Monopoly, doubles are my friend. 1 butane? Make it 2. 6.5 oxygens? Make it 13. 4 carbon dioxides and 5 waters become 8 and 10 respectively. In your face, chemistry police! While using an unconventional coefficient work to balance the equation initially, multiplying the coefficients by some factor, usually 2, will ensure everything is proper. Sometimes when we see an equation, we can't help but feel like Calvin's mom and that it's too much to handle. But for perhaps the only time ever, Calvin's dad has some sensible advice. But how do we? Well, alright, let me show you the way. Notice that there is NH4 on the left, and then another NH4 on the right. Same goes for PO4 and NO3. These polyatomic ions may not be individual atoms, but they don't change either. This means we can substitute in whatever we want in order to simplify what we are looking at. I'm going to replace NH4 with X, PO4 with Y, and NO3 with Z. Counting the atoms is much simpler here. 3 X's, 1 Y, 1 lead, and 4 Z's on the left. 3 leads, 4 Y's, 1 X, and 1 Z on the right. So on the left I need to quadruple Y, which also gives me 12 X's, and I need to triple lead, which gives me 12 Z's. All that's left is to get xz on the right equal to the left, and it just takes a 12. If you've seen a few of my videos, you're probably thinking that there's no way it can be this simple and there must be some sort of catch. But let me assure you that for once I am being serious. So to prove it, I'll count the atoms in the traditional way. By doing so, you should see the usefulness of substituting those polyatomic ions for something more manageable. There are 3 nitrogens in ammonium phosphate and 4 in lead nitrate, which gives a total of 7 on the reactant side. Hydrogen with 12 and phosphorus with 1 are easy to count, but then there are 4 oxygens plus another 12 oxygens for a total of 16 on the left. Finally, there is a single lead, and we are done with the count of the reactants. Luckily, the products are a bit easier to count. Nitrogen only shows up in one product, and there are 2 of them. There are 4 hydrogens, as well as 4 phosphorus atoms. Oxygen is again split with 16 in the first product, and 3 in the next for a total of 19. We finish with lead, which there are 3. Starting like before, I will put a 4 in front of the first compound. Nitrogen count increases from 7 to 16, hydrogen quadruples to 48, and phosphorus becomes 4, which makes it the first element balanced, and the oxygen total is now 28. Adding the 3 in front of the lead nitrate triples the amount of lead to 3, which is now balanced. Nitrogen increases again and is now totaling 24, and oxygen increases to a new total of 52. All that's left is to add a 12 in front of the ammonium nitrate. The nitrogen becomes 24, hydrogen 48, and oxygen 52, which means we have finally balanced this equation. Both methods work, and you will figure out which one you prefer to use. I know that coding and recording the substitution method was easier and faster than the traditional. So we have learned 2 new techniques to balancing difficult equations. First, we can use substitution to balance equations with lots of polyatomic ions. Second, we can use a decimal to balance the equation and simply adjust to whole numbers after. These tips are useful, but if you prefer something different, to quote Calvin, Go with what works, I guess. As I close out the video, I will put some practice up for you to try. Focus on applying the techniques instead of the potentially questionable chemistry. Before they are presented though, thank you very much for watching. Feel free to suggest a video topic or letting me know how you did on the practice by leaving a comment below. Good luck!